lecture of the heat equation. Today I am going to discuss those type of questions in which the temperature at the end of the bar is non-zero in both steady state condition and unsteady state condition. So this is your type 3, when temperature at the ends of the bar is non-zero in both steady state and unsteady state condition. Now here, in this case, our solution will be uxt equal to u1x plus u2xt. Now u1x will be where u1x is the steady state solution and u2xt is the unsteady state solution. So this is your required solution. uxt equal to u1x plus u2xt, where u2xt is the unsteady state solution. So let us start with the problem. So here is the problem. A bar 10 centimeter long had with insulated sides had ends at temperature 20 degrees centigrade and 40 degrees centigrade until the steady state condition prevails. So this is your temperature at the ends when your steady state condition prevails, until the steady state condition prevails. Now suddenly the temperature at A, say the first point at A, raised to say 50 degrees centigrade, and at the same instant temperature at B is lowered to 10 degrees centigrade. Suddenly the temperature at A is raised to 50 degrees centigrade, and at the same instant the temperature at B is lowered to 10 degrees centigrade. So our problem is to find the temperature uxt for some point P and for some time. So we have to find out this temperature. So solution. So in steady state condition, we know that the temperature uxt is equal to theta 2. Theta 2 means the temperature at B minus theta 1 divided by the length of the rod into your x plus theta 1. So this is your formula for the steady state temperature for the steady state condition. Now here you can see that your theta 2 is 40 minus 20, so that means this will be your 20 divided by 10, length of the rod is 10, into x plus theta 1 is 20. So this will be your 2x plus 20. So this is your temperature in the steady state condition. Now you are seeing that suddenly the temperature at A raised to 50 degrees centigrade, as temperature at A is raised to 50 degrees centigrade, hence it means now your steady state condition will become your transient phase. So as temperature at A is raised to 50 degrees centigrade, hence we have the transient phase. That means we have the transient temperature. So hence now you can see that when your length of the rod is 0, when at A, that means when your x is 0, your temperature is 50 degrees centigrade, and when the rod bar has length 10 centimeter, your temperature is lower to 10 degrees centigrade. So that means your boundary conditions are, hence when the length of the rod is 0, your temperature is 50 degrees centigrade. Hence boundary condition are so your U0T will be 50 degrees centigrade. Your ULT, that means when your length is 10, your temperature will be temperature at V is 10 degrees centigrade, and your initial temperature, that means your temperature in steady state condition, that means when your temperature does not depend on time, that means your initial temperature is equal to 2x plus 20. So this will be your temperature. Now here you can see that, so the boundary condition in, now these are the boundary condition in unsteady state condition are these. So now as you can see that the temperature at the ends is non-zero, so we will try, as the temperature at the ends is non-zero, so we will try to make this temperature to 0. We will try to lower this temperature to 0. So for that, as temperature at A and B, is non-zero, so for zero boundary condition, that means zero boundary condition means to make your temperature at A and B 0, we split our solution. So for zero boundary condition, let us split our solution. As uxt equal to u1x plus u2xt. Now your u1x will be the steady state temperature, where your u1x will be the steady state temperature. So u1x is theta 2 minus theta 1 divided by theta 1 into x plus theta 1. Now the temperature at B is 10, so this will be 10, and temperature at A is 50 divided by the temperature at A, the temperature at B minus A divided by the temperature at A, which was your 50, into this is your L, that was your 10, into x plus the temperature at A, and the temperature at A was 50 degrees centigrade. So this is equal to minus 4x plus 50. Now this is your steady state temperature, because you can see that after that initially the temperature at A was, I think the temperature at A was 20 degrees centigrade and the temperature at B was 40 degrees centigrade, and then suddenly the temperature at A is raised to 50 degrees centigrade, and at the same time it is lower to 10 degrees centigrade. So our steady state solution will be theta 2 minus theta 1 divided by L into x plus theta 1, which is equal to minus 4x plus 50. Now the boundary condition for, now this is your transient solution, where this is your steady state solution, where again transient solution is, so u2x2 will be your a cos lambda x plus b sin lambda x into e to power minus lambda k square t. So this is your solution for the transient phase, where your boundary condition will be, now you see that your boundary conditions are, that means boundary condition for uxt will be uxt minus un(x). So from here you can see that if your x is 0, so from here you can see that if your length of the rod is 0, then this will be your u0t minus un0, and your u0t was 50 degrees centigrade and un0 is, from here you can see that your un0 is 50, so this will be 50 minus 50, that means 0 degree centigrade. Hence you can say that we are able to make our temperature at the ends as 0. Similarly, when your length of the rod is 10, this will be your u10t minus u110. This was, I think, your initially this temperature was your the temperature at B was 10. The temperature at B was 10, so this will be your 10 minus un10. Now here you can see that your un10 means when your x is 10, this will be your minus 40 plus 50, that means it is again 10, so this is your 0. Then your u2, now from here you can see that our u2, when your time is 0, that means initial temperature. So this was your, I think, 2x plus 20. This was your 2x plus 20. Now it is your minus 4x plus 50. So that means it is equal to, so this is equal to 6x minus 30. So this is our 6x minus 30. So we have the steady state solution. So we have already evaluated u1x. Now to get u2xt, our solution is this one with boundary condition, these three are the boundary condition. You can see that your temperature at the ends is 0 with your initial temperature as 6x minus 30. So now let us find out its solution. Now using boundary condition u20t equal to 0. u20t means when your x is 0, so this will be your sin 0 is 0. So we have 0 equal to a cos 0 is 1 into e to power minus lambda k square t. So from here you consider your a is 0. Using boundary condition u2 equal to 0, that means when your x is 10, a is already 0. So in the left hand side we have 0. Here we will have b into sine 10 lambda into e to power minus lambda k square t. Now here you can see that your b cannot be 0. Here your b cannot be 0, so your sine 10 lambda will be 0. So this is your sine n pi. So your lambda will be n pi upon 10. So this is your lambda. Now let us use the third condition. Therefore your solution will be, therefore your uxt is a cos lambda x, a is 0. So we will have b sin lambda x into e to power minus lambda k square t. And your general solution is in transient phase, general solution in transient condition is u2xt is equal to summation n equal to 1 to infinity bn sin lambda x into e to power minus lambda k square t. So this is your solution in the transient phase. Now let us apply the third boundary condition again, as your u x0 was 6x minus 30. So here you consider if your t is 0, then in the left hand side we will have 6x minus 30. In the right hand side we have n equal to 1 to infinity into bn. The value of lambda was n pi upon 10. So this will be n pi upon 10 into x into e power minus 0, because we have taken t as 0. So that will be e to power 0 is 1. So that will be your 1. Now here you can see that this is your half range sine series. So in half range sine series, our Fourier coefficient will be 2 upon L, 0 to L, fx sine n pi x upon L. Here the length of the rod is 10, so L will be 10. So this will be 2 upon 10, 0 to 10. Your fx means the function is 6x minus 30 into sine n pi x upon 10 into dx. So this is equal to 1 by 5. Now we can integrate this term. Integration of sine will be minus cos into n pi upon 10 into 10 upon n pi. Then here the differentiation of this one will be 6, and the integration of this bracket will be 10 square upon n square pi square, and then the limits will be from 0 to 10. Again you can see that here your upper limit and lower limit will be 0, because we are putting x equal to 0 and x equal to 10. So this term get vanished, and this term will be for the upper limit, this term is your 10 into 6, that means this will be your 60 minus 30, so that is your minus 30, that will be your 30, and this is your minus sign, so this will be minus 30 into 10, so this will be 300 divided by n pi. Now as your x is 10, so this will be your cos n pi. Cos n pi is minus 1 for n. Now if your x is 0, then we will have minus sign here, and one minus sign is already from the negative lower limit, so this will become plus, and again this is your minus, so this will be minus, and cos 0 is 1, so we have 10 upon n pi. So here you can see that if we take 10 upon n pi common with negative sign, then this will be your 2 upon n pi, and here we have taken 10 common, so this will be 30 into minus 1 to the power n plus 1 with minus sign here. I think this lower limit will be your, when your x is 0, this will be your minus 30 into 10, so this will be your minus 300. So your 300 is common, so this will be your minus 60, and here we will have minus 1 to the power n plus 1. So we have the value of bn, hence your uxt will be thus. Therefore our uxt is equal to n equal to 1 to infinity bn is minus 60 upon n pi into minus 1 to the power n plus 1 into sine lambda was your 10 upon 10 n pi upon 10 into e to power minus lambda was your n pi upon 10 k square t. I think this is not your solution. This will be your k lambda square t. This will be your k lambda square t. So here we will have k lambda square t. K lambda square t. Because the solution is a cos lambda x plus b sin lambda x into e to power minus k lambda square t. So now if you put the value of lambda here, so this will become your minus k n square pi square upon 100 into t. So this is your uxt. Now therefore your final solution will be, your uxt will be your u1x plus u2xt. So hence our solution is this one, and your u1x was, we have already calculated our u1x, and this was your minus 40x plus 50. So u1x was your minus 40 minus 4x plus 50, and then your u2x is minus 60 upon n pi minus 60 upon pi. And here you can see that if your n is 1, then this will be your 0, and if your n is 2, then this will be your, if your n is 2, then this will be your plus 1, and that is your plus 1, that means it will be your 2. So we can write it as minus 120, so this will become your 120 upon pi when your n is even. So here in the summation we will write n equal to even. So in the summation our n is from 2 to infinity, that means when your n is even, and now here we will have 1 by n, or you can say 1 upon n sine n pi x upon 10 into e to power minus k n square pi square t upon 100. So this is our solution in this case.